Day 790 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3286. Find a safe walk through a grid. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n binary matrix grid and an integer health. You start on the upper left corner 0, 0 and would like to get to the lower right corner n-1 and n-1. You can move up, down, left, or right from one cell to another adjacent cells from one cell to another adjacent cell as long as your health remains positive. Cells I and J with grid of I and J equal 1 are considered unsafe and reduce your health by 1. Return true if you can reach the final cell with a health value of 1 or more and false otherwise. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input grid equals a 2D array of integers or a binary grid, first row being 0, 1, 0, 0, 0, middle row being 0, 1, 0, 1, 0, bottom row being 0, 0, 0, 1, 0. Now, I also want to make sure you understand that each one of these arrays is a different row. So as you can see, this is going to match this top row, then this row is going to match this middle row, and then this row is going to match this bottom row. So this is what our grid looks like over here. Boom. We have a health of 1, the output is true. It shows us the path we could take, right? We could just go just like this here, or we could follow this gray path here. And as you can see, we don't come across any unsafe cells that are marked as 1, right? So we follow the 0 cells all the way to the end without losing any health points, because remember, every time we cross one of these unsafe cells with a 1, that's going to reduce our health by 1. So if we cross 1, we will have a health of 0 because we start with a health of 1. And it says we want to return true if we can reach the final cell with a health value of 1 or more. So since we only start with 1, that means we cannot lose any health on our way to the end of the grid, which we didn't, right, by following all these zeros. So that's why the output is true. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input grid equals a binary grid. First row 0, 1, 1, 0, 0, 0. Next row 1, 0, 1, 0, 0, 0. Next row 0, 1, 1, 1, 0, 1. And the last row 0, 0, 1, 0, 1, 0. Health equals 3. This time the output is false. It says a minimum of 4 health points is needed to reach the final cell. So here, now I'm going to delete this since y'all already know how these arrays work. Here, it's impossible for us to get all the way over here. We would need at least 4 health points, but we only have 3, right? We go down, we lost a point here. We might go here, we lose all 3. We go this way, we go here. But if we go 1 here, we lose our health. We lose 1. Then here we lose a third. A second. Then we come here, we lose a third. So we can't take this path because that would be all 3 of our health points. We can't come this way because we're going to lose 2 right off the back. And then eventually right here, we would lose a third. So long story short, it's impossible to do it with 3. We would need 4 health points for this array or this grid right here. And finally, for example 3, in example 3, our input grid equals a 2D array of integers or a binary grid. First array being 1, 1, 1, next array being 1, 0, 1, and the last array 1, 1, 1. Again, this time health is 5. The output is true. It says the final cell can be reached safely by walking along the gray cells below. So they show us this path. We come here, boom, boom. This is only going to take 1, 2, 3, 4 health points. but we have 5, so we're good because we'll still be left with 1. It says any path that does not go through cell 1, is unsafe since your health will drop to 0 when reaching the final cell, y'all. So boom, since we have 5 here, we could just use up 4 when we take this path. So boom, y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we are going to come all the way down here, and we are going to create a struct, and we are going to say, struct node colon. It's going to be comparable. We'll open up the brackets, and we need to get the grid position. So we declare a variable called R colon, that's going to be an integer. Declare a variable called C colon, that's going to be an integer as well. Then the total accumulated cost to reach this position, we'll declare a variable called cost colon, it's going to be an integer. And this allows node objects to be ordered in the min heap. Nodes with smaller costs have higher priority. So we'll say static func is less than, open up the parentheses, underscore LHS colon node comma underscore RHS colon node. Then we are going to come outside of this, and it's going to return a boolean. Then we're going to open up the brackets, and we'll say LHS.cost is less than RHS.cost. Boom. Now that's just for that part. Now we need to get back into the main function. So first thing in the main function, we need to get the number of rows and columns in the grid. So we're going to say let m equal grid.count, and then we're going to say let n equal grid square bracket 0, come outside of that and say dot count. Boom. Then we need 4 possible movement directions, right, down, up, and left. So we're going to say let directions colon square bracket, open up the parentheses, say int comma int. We're going to come outside of that, and we're going to say equals. We're going to open up the brackets. It's going to be an array of tuples. So we're going to say, first we're going to say 0, 1, come outside of those parentheses, put another comma, open up some more parentheses. We're going to say 1, 0, come outside of those, put another comma, open up some more. We're going to say negative 1, 0, come outside of that. We're going to say comma, open up the parentheses. We're going to say 0, -1. Boom. Then we're going to come underneath that, and we're going to initialize a very large value to represent not reached yet, but we need to store the minimum health cost found so far. So we're going to declare a variable called best cost. It's going to say colon to the array of integers. Come outside of that, we're going to initialize it with an array. Open up the parentheses. It's going to be repeating colon another array, open up the parentheses, and that's going to be repeating colon 10 underscore 000 comma count colon n, come outside of that, comma count colon m. Boom. Now we're going to use a min heap used by Dijkstra's algorithm, and cells with the smallest accumulated cost are processed first. So we come underneath this, declare a variable called heap. We'll set that equal to a heap less than node greater than parentheses. Boom. Now we need to start at the top left cell, and then the initial cost includes the value of the grid 0, 0. So we'll come right here, or this first, the initial value, we got to include this first grid in the initial value. So we're going to say heap dot insert, open up the parentheses, node, open up the parentheses, R colon 0 comma C colon 0 comma cost colon grid square bracket 0 square bracket 0. Now we're going to use Dijkstra's shortest path algorithm. So we'll come underneath this and we'll say while let node equals heap dot pop min, open up the parentheses, come outside of that, open up the brackets. We're going to say let r equal node dot r. We're going to say let c equal node dot c, and we're going to say let cost equal node dot cost. Boom. Now, if we've already found a cheaper way to reach this cell, then we'll ignore this outdated heap entry. So we can say guard cost is less than best cost, square bracket r, square bracket c, come outside of that, else, open up the brackets, and we can just say continue. Boom. Now we need to record the best known cost for this cell by coming underneath this. We're going to say best cost, square bracket r, square bracket c, equals cost. Boom. And if we've reached the destination, we can stop. This Dijkstra's algorithm guarantees this is the minimum possible cost. So we'll come underneath this and we'll say if r equals m minus 1, comma c equals n minus 1. We'll open up the brackets and we can just break right there. Now we need to explore all neighboring cells. So we're going to come underneath this and we're going to say for, open up the parentheses, dr, comma, dc, come outside of that, in directions, we're going to open up the brackets and we're going to say let nr equal r times dr, and we're going to say let nc equal c times dc. Then we're going to skip positions that are outside the grid. So we're going to say guard nr is greater than or equal to 0, comma nr is less than m, comma nc is greater than or equal to 0, comma nc is less than n. Else, open up the brackets and we can continue. Boom. Now the cost of reaching the highest, or the cost of reaching the neighbor through the current cell is, we're going to handle that by saying let candidate, sorry, I'll check my spelling, let candidate equal cost plus grid, square bracket nr, square bracket nc. Boom. If this path is potentially better than what we've recorded so far, we'll add it to the heap for processing. So we come underneath this and we say if candidate is less than best cost, square bracket nr, square bracket nc, then we're going to open up the brackets and we're going to say heap dot insert, open up the parentheses, node, open up the parentheses, r, colon nr, comma c, colon nc, comma cost, colon candidate. Boom. Then we need to come down here and we say return health minus best cost, square bracket m minus 1, square bracket n minus 1 is greater than or equal to 1, y'all. Boom. So let's go ahead and give this a run, make sure it runs properly before we submit it, and we have our first error. So let's see. Oh, this should be insert, not inset. So now let's run that again, see if that fixed it. Wrong answer. Okay, so most of the time if we got the wrong answer, that means somewhere that the math is not math. And so give me a moment while I check this math, see if we can figure out what is going on. Okay, one moment, y'all. One moment, y'all. It's a lot of stuff going on. Oh, sorry, y'all. So this should be R plus DR, and this should be C plus DC, y'all. So now let's give that a run, see if that did the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 13 milliseconds beats dash percent of users, y'all. Not too bad at all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom. And this is the rest of the bottom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.